So this is example 13. You guys are going to do this one on your own because we're going to work 14 instead, and 14 is a little bit more difficult. It's the same process, but you're finding the new payment, which we know how to do if the term stays the same, and then you're just transferring with the new piece here. Okay, so again, it's real similar to 14, so we're going to do 14. Okay, so an $80,000 home loan is obtained for 20 years at 6% interest compounded monthly. In 6 years, the rate is raised to 7.5% compounded monthly. Okay, so again, this is a refinancing option. So we have to compute the new payment if the term of the loan remains the same. So first thing we have to do here is we have to figure out what the current monthly payment is. Then we have to figure out how much we still owe, and then we're going to use that amount that we still owe to find our new monthly payment, so the refinancing payment. Okay, so first step is we're going to make, so we have 20 years, 80,000, and then in 1 month we make our regular payment, in 2 months, okay, and then again at the 6-year mark, that's where we switch to a new R. So I'm going to call the first payment R1 and the second payment R2. Okay, so again, we kind of have two different pieces going on here. Okay, so in the 20-year mortgage, so I'm going to work it over here in a 20-year mortgage, our interest rate is 6% compounded monthly. That means that I is going to be 0.06 over 12. Okay, so R1, before we do that, we need N. So N here would be 12 times 20. So give us 240 payments that we would be making without that piece. So our R1 is going to be 80,000 times 0.06 over 12 over 1 minus 1 plus 0.06 over 12 to the negative 240. So this is the A sub n formula for R, so we're just flipping it. This is the same A sub n thing, it's just on its head. It's a reciprocal, so I'm just using that straight formula to do that. So when we put this all in, it's going to look a little different on our calculator. So we do our 80,000 times our numerator 0.06 over 12, and then we divide that by our denominator 1 minus, and then second the parentheses 1 plus our I 0.06 over 12. Okay, so to the negative 240. So we get $573.15 because we get 0.44. So again, we're going to round up because it's payment, so 15 cents. Okay. So now with this payment, what we're going to do is we're going to kind of, we have to figure out how many payments we've paid in so far. Okay. So we have to figure out how much we owe. So this is going to be our principal for the new loan. Okay, so it's what we owe so far. So for 7 or 6 years in, then it's going to be 12 months of 6 payments, so that's 72. So we're going to use our leftover formula for 72, so after the 72nd payment. So that's going to be the 4.1 formula, 80,000 times 1 plus I, 0.06 over 12, to the 72, because we're taking 72 periods forward, so that's this bit right here, minus 5713.15. So we're taking, this is our payment, and then that's an S sub n problem, so we have 1 plus our I to the 72, because again they're going to match this time, minus 1 over 0.06 over 12. Sorry. And when we calculate that, I'm just going to enter the whole thing in again. Here's our numerator. Here's that denominator. So again, notice I'm doing 2 sets of parentheses, 1 for my numerator, and it's here, and then 1 for the 1 plus. So that means so far that we have 6 $65,038.31, rounding to the nearest penny. And now we're going to take this to use it to find our R2. Okay, so I'm going to construct a new timeline, and this is my loan amount now, this bit that we just found, so I'm going to put that over here. 65,038.31. 1 month later we're going to pay our R2, then another month after that. And again, this is at the 6-year mark, and now we're at 20 years. This is 6 years, 1 month, 6 years, 2 months. All the way to the 20-year mark. So to figure out our N, we're going to take our 240 from up here and subtract our 72, because that's how many payments will be left in the mortgage. And we know to do that because of up here it says if the loan of the term remains the same. Okay, so the loan of the term remains the same. So then our N here is going to be 240 minus 72. So it's 168. And now we're going to use the same formula up here, only this is different now and this is different now. That's it. Okay, and we expect this one to be bigger because now we have a different interest rate too. Here this time our R is 0.075, still monthly. So that means our I is 0.075 over 12. Okay, and then we're going to use this to calculate R2. So that's 65,038.31 times 0.075 over 12 divided by 1 minus 1 plus 0.075 over 12 to the negative 168. And putting that in our calculator. There's our numerator. Now we do our denominator, our 1 plus. So our new payment is $626.43 because here, or sorry, 42 cents. We get 626.41 and then we're going to round up because it's a payment, so 626.42 would be our new payment. Okay, so we're in example 14, part B. We want to find the new term of the loan if we don't change the monthly payment, but we have the new R. So again, I'm just going to make a fresh timeline here. So we still have $65,038.31 left on the loan. This is what we're trying to find, is how much we're paying, but we're still going to use our R1. Remember, R1 from the previous problem we just did was 573.15 cents. And again, that's from part A. Okay, so now we're going to figure out what N is. So we're trying to figure out the number of payments that are left on the loan. Now remember, up here there were 168, so because we have a new interest rate here, we expect there to be more than 168 because we have a higher interest rate and a but the same monthly payment. So we're going to be paying more interest. Okay, so it should be bigger than 168 that we got up here. If it's not, something went wrong. So we're going to set this up the same way that we've set up these type of problems before. We also want to find the concluding payment, so remember that's one period after we make so many full payments, so that's the smaller payment 1 month later. So I'm just setting up my A sub n here. And again, n is the unknown because we're trying to find the new term. How many payments would we have left? And we're just going to use n. We're not going to worry about dealing with it with the 20 years. We just know that we should get something bigger than 168 because that's how much that was left on the original loan. Okay. So first step is we divide by this. This time there are no nice numbers to cross off, so we're stuck with pretty yucky fraction, but that's okay. Then we're going to multiply our denominator over, because again we're trying to get this term alone, so we can take the natural log, so we have to get rid of this and then get rid of this. Hopefully you're getting good at that now because you've been doing it a lot. If not, that's why we have practice problems. Okay, so we're going to move the 1 over. So now we have the piece with the exponent by itself. So now we need to flip the sign because we want to get rid of that negative. So I'm going to do that again in a thicker marker. It is a different color, but I'm not sure if that shows up on the video here. Okay, and then we're going to take the natural log of both sides. So it's the natural log of this whole bit and then the natural log of this whole bit. The properties of natural log let us bring the power down. So now we have negative n equals, sorry, positive n equals the negative natural log of this side, 1 minus 65038.31 over 573.15 times our interest rate. And that's going to be divided by this piece, because again this comes down. So that's why I'm just going straight to this, skipping a step here. But again, after you do this enough, it just becomes second nature. You know exactly what to do. And when we put that whole thing in the calculator, opposite of the natural log of 1 minus 65,038.31 cents divided by 573.15 cents times our interest rate. And I had an extra parenthesis in there, so I want to make sure I have that so I don't get an error. Divided by the natural log of 1 plus I. So we get n is 198.24. Okay, so that means we're going to have 198 full payments. That makes sense because it should be more because we're paying the same rate. But we have a higher interest rate, so it's going to mean it's going to take longer for us to pay off. So again, we want to make sure our answer makes sense. And now we have to use the leftover payment. So we know we have 198 full payments of $573.15 and 1 smaller payment of, and then this is going to be our answer. But we want to fill in that blank, so to do that we have to use our 4.2 formula. So that's just like the one we used up here, but this time it's going to be SN due instead of SN, so we're going to multiply it by 1 plus I, and then here we're going to multiply this by 1 plus I, so it bumps that piece up one more with our exponent rules. Okay, so I'm just going to fit that in this little space right here. So again, that's going to be our current loan amount, $65,038.31 times 1 plus 0.075 over 12, and that's going to be to 1 plus our n. This time our n is 198, so it's going to be 199, and then we're going to subtract that from 573.15 times 1 plus our I, 0.075 over 12, to the 198 minus 1 over 0.075 over 12, and that whole thing gets multiplied by 1 plus 0.075 over 12. I know that's not very pretty, and I kind of had to bunch it in there. I apologize. So when we plug in that whole thing, So again, here I have my piece. I just want to make sure all my numbers are right. So 1,368 to the 99. Again, that's one more than what we had before. Two sets of parentheses here, numerator, and then my 1 plus, and the 1 plus, and the numerator, so that looks good. Here's my denominator, and then here's my 1 plus I, because it's as an SN due. So then our smaller payment, which we know should be smaller than this, we got $141, and I would just say that's 94 cents. Because when it's that last payment, it's okay to round like normal. Okay, so we'd have 198 full payments of $573.15, and one smaller payment of $141.94.